Hello, this is Ms. DB, and I'm going to do an example of how to find the roots of a polynomial function. And the example that I'm going to do is actually on your worksheet. So if you are watching this, open up your worksheet and do some of the work as you go. So you have to know the rational root theorem, which says that if the polynomial p of x has integer coefficients, those are the numbers in front of the x terms, then every rational root of the polynomial equation can be written in the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So what does that mean? That means here's the coefficient, here's the constant, -36, and here's the leading coefficient is 1. So if I write all the factors of the constant term, which is all the factors of -36, and the factors that would be divided by all the factors of the leading coefficient, which is just 1. So all I really have to do, get my pen here, is write all the factors of -36. And I would divide each of those by the number in front of this term, but it's just 1 in this case. All right, so the possible roots are going to be, let's see, the factors of 36 would be plus or minus 1 times 36, and it would be plus or minus 36. And the reason I put plus or minus is because you could have 1 times 36, that's 30, or I could have 1 times -36, which would be -36, or I could have -1 times +36. I could have plus or minus 2 times plus or minus 18, because 2 times 18 is 36, 1 needs to be negative. I could have 3 times 12, 1 has to be negative, so I put the plus or minus. 4 times 9, and again, plus or minus, because 4 times 9 is 36, and squeeze in a 6. 1 would have to be negative, 1 would have to be plus. So I've got, these are my possible factors, and those are going to be the roots. Now only 4 of them, because this is a degree of x to the 4th, which means that there are going to be exactly 4 roots for the equation. So I already used the rational root theorem to identify the rational roots. That's the first step. And here's all my possible roots. And they're the same as the ones I wrote down over there. Now my next step is I'm going to graph this so that I can see which ones would make the most sense. So on Sketchpad, go to Graph, Plot New Function. You can also do this in your graphing calculator. You don't have to share your graph with me unless you want to, but you do want to graph this to throw out some of these possibilities, because there's so many that will just take forever to check them all. So I want to find the most likely ones here. Plus 5x squared minus 27x minus 36. I don't put the equals 0 part in. I'm saying that f of x is equal to this. And I'm looking for where it crosses the x-axis. Those are going to be my possible zeros. Now you might want to make this, change the scale so that you can see more of the graph or less of the graph, depending on. Right now it's set to be square, so that as the intervals in the x-axis increase, the y ones do at the same rate. But I could change this to grid form rectangular, so that I could change just one of these at a time, like that. It might be easier to find to see what my graph looks like. So you can see that the bottom of the graph, then the minimum is actually at about -80. Not that that matters for finding the roots. For the roots, we only need this point and this point. So I can see that it looks like it's at -1 and 4, right? Now, if you can't tell, you could put a point at the intersections of those, and then you can measure the coordinates of those, but these ones are not hard to tell. Yeah, 4 and -1. Okay, so that means that I found 2 real roots. Let me move this down so you can see there. That looks more like what you would see on a graphing calculator, and it looks like the real roots are really close, or exactly -1 and 4. All right, now we're going to test those ones that we just found. And to test these, you could use long division, or you could use synthetic division. I'm going to use synthetic division. So I'm going to first test the root of -1. So I'm going to put all these coefficients from my function and make sure that let's see, x to the fourth, x to the third, x squared, x, that's in descending order. So 1 is the first coefficient, then -3, 5, -27, and -36. Now to use synthetic division, you drop the first one down, 1, and then we multiply. -1 times 1 is -1, and you put that answer under the -3, and then you add these two numbers together. -3 plus -1 is -4. And then you multiply -1 times -4, and you get 4, and you put that under the 5, and you add those two together. And then you multiply -1 times 9, and you get -9, and you add those two together. And then we multiply -1 times -36 is a +36, and we add these two together. Since we got a 0, that means that -1 is indeed a root. So that's good. That means that x plus 1 would be one of the factors. You use the opposite sign. Because x plus 1 equals 0, you'd solve that for x and you'd get -1. Now, what is the rest of it? If x plus 1 is a factor, the coefficients along the bottom here are going to be what remains after you factor x plus 1 out. So this would be 1x to the third, because you reduce each exponent from the original function by 1. So I'm going to start with 1x to the third minus 4x squared. These numbers are coming from my last part of the synthetic division, plus 9x minus 36. Okay? Now I also want to test the function of 4. I could go back and test 4 into the original function with synthetic division, but it would make more sense to check it with this remaining cubic function, this remaining x to the third minus 4x. So I'm going to put 4 here, and then the coefficients of this part. So 1, because there's no number in it, that could be a 1, minus 4, -4, 9, and -36. Okay, now I'm going to do synthetic division again. I drop down the 1, and I go 4 times 1 is 4, and I put that here. And I add these together, and I get 0. I need a little more room here. And then I go 0 times 4 is 0. 9 plus 0 is 9. 9 times 4 is 36. And you get a 0, which means that 4 is a root as well. So now I already had the x plus 1. Now I also get that it's x minus 4. Remember to use the opposite sign. And then what would be left is this would be 1x squared, because squared is 1 less than the cubed. So 1x squared plus 0x, which you can write if you want. Most people wouldn't though. Plus 9. Let me write that without the 0x, because then you might recognize, oh, I think I could factor that. Whoops, sorry. I hope that didn't disappear, because it did. Dumb thing. That was a 1. This sketchpad has a very bad function of erasing if you move up. That was 36. This was 0. So let me make sure I don't. So now I would have x plus 1 times x minus 4 times x squared plus 9. Okay, and now I want to set this equal to 0. So my possible roots would be x plus 1 equals 0. Well, you know the answer for that one already. We already did that one, and we got x equals -1. Another root would be x minus 4 equals 0. We already did this too, and we got x equals 4. We looked at those from the graph. And now to find the other one, let's set this equal to 0. It's not going to factor like I originally thought. If it would have been x squared minus 9, it would have factored, but it's a plus. So let's do it this way. I'll subtract 9 from both sides, and I'll get x squared equals -9. -9 is interesting, because when you take the square root of a negative, so we'll get x equals the square root of I times the square root of 9, or that's 3i. And it's also plus or minus. When you take the square root, you get a plus or minus there. So those are the two complex roots that would be in this as well. So we knew that it should have 4 roots because this was x to the 4th. And we had found our real roots already. So I see some of my stuff erased. Why did it do that? Let's see if I can get it to come back. No. Oh well, it's okay because it's over here as well. So we had found our complex roots, and then that means that our fully factored form of this would be x plus 1, x minus 4, x plus 3i, x minus 3i equals 0. And the solutions, which is our roots, would be 4, negative 1, 3i, and negative 3i. You can't see the 3i and the negative 3i in the graph, but you can see the real roots of 4 and negative 1. And that's how you would do this problem and how you do similar problems to this. Thank you very much. Let me know if you have any questions or if you need more help on the other problems like this.